Hi everybody, and welcome back to page 115 in the workbook. We're going to talk through theorems 15.3 and 15.4 in this video. Okay, let's start with theorem 15.3. This is called the first isomorphism theorem for rings. And it starts us off with a ring homomorphism, phi going from R to S, and tells us that the mapping that takes us from R mod the kernel to phi of R, defined by this, is an isomorphism. Okay, and I want to just look back at the diagram that we drew in the previous example just to illustrate what this all means here. Okay, this is the same correspondence that we noticed in example 2 above. Okay, so R plus the kernel of theta would be something like, just to take a specific value of R, it would be something like this. Okay, so if R is 1, this would be R plus the kernel. Remember that we wrote K for the kernel in that example. And then what that's mapping to, the output, is over here. That's just phi of R, where again R is 1. So the correspondence that they're describing to us down here is exactly the same correspondence that we noticed in the picture that we drew above. Okay, this theorem is formally telling us that this is an isomorphism. Okay, and so to kind of sum it all up then, tells us that these two rings are isomorphic. R mod kernel of phi is isomorphic to phi of R, the image of R. Okay, and if you look back at chapter 10, you will notice that this theorem is really analogous to the first isomorphism theorem for groups that you talked about there. Okay, now what about theorem 15.4? Okay, so this tells us that ideals are kernels. Let's read this together. So every ideal of a ring R is the kernel of a ring homomorphism of R. In particular, an ideal A is the kernel of the mapping taking R to R plus A, okay, from the ring R to R mod A. Okay, you can kind of think through that a little bit maybe, but I just want to make one comment. Okay, this is really the analog of theorem 10.4, back when you talked about group homomorphisms. Okay, it said something like the fact that normal subgroups are kernels. Okay, this is saying the analogous thing about the fact that ideals are always kernels when we talk about ring homomorphisms. Okay, so you can maybe look back at theorem 10.4 and compare it to this theorem, 15.4, that we're looking at.